Alright, so now we are going to do acids, bases and salts. Now why is it named like acids, bases and salts? Why are these three things put together? Now we know that acids, we have a faint idea that acids are substances containing H plus ions, or rather we can say substances which release H plus ions, and bases are substances containing OH minus ions, and salts are neutral. That means they neither contain H plus ions nor contain OH minus ions. Now acids, bases and salts, they are like a transition from each other. Like you can go from, if you have suppose H plus ions and you start decreasing the number of H plus ions, then what will you get? Lesser number of H plus ions, and a point will come when the number of H plus ions will become 0, and when this becomes 0 it becomes a salt. And then after 0 you start increasing the OH minus ions, and as you increase the OH minus ions it becomes a base. So this is a very vague idea of acids, bases and salts. Let us see what are the differences. Now these acids, as we know, they release H plus ions in aqueous solutions. Aqueous solutions means solutions of water, where water is the solvent. Bases release OH minus ions in the aqueous solution, and salts neither release H plus nor OH minus. So salts are neither releasing the hydrogen ions, H plus ions, nor the OH minus ions. They release some other kind of ions. Secondly, acids are sour to taste. You know this vinegar, which is ethanoic acid, if you have tasted vinegar, that is also sour to taste, and that is the property of the acid. Because it is ethanoic acid, it will be sour to taste. Bases, on the other hand, are bitter to taste. You know these antacids, like these gelusil and all, they contain bases so that they neutralize the acid in our stomach. We'll learn about that later. But if you see that these medicines or antacids will be very bitter to taste. Like medicines are bitter and most of them contain bases. That is why they are bitter to taste. And salts, on the other hand, can have any taste. Like our common salt has a salty taste, but if you have baking powder and stuff, it has a different taste. Baking powder is also a kind of, not actually a salt, but it's not an acid, it's not a base. Actually baking powder is not a salt. You have all these NaCl, then suppose Na2SO4, all these are salts. Na2SO4, K2SO4, KCl, these are all salts, and their tastes may vary. Some of them may even be poisonous, so they haven't been tasted. Thirdly, you might have heard about the litmus test. Now acids will change blue litmus to red, and bases will change red litmus to blue. Now acids do not affect red litmus and bases do not affect blue litmus. If you should not get confused, acids will only change blue litmus to red. If you have red litmus, acid will not change it to blue, or acid will it will not just do anything to that litmus. The litmus will remain red. But bases, on the other hand, will change that red litmus to blue. But bases will never affect blue litmus. The blue litmus will remain blue in case of bases. And salts, they neither affect blue litmus nor red litmus. Then acids will have a pH less than 7. Now pH is a scale on which the concentration of or the number of hydrogen ions is measured, and acids will have that pH less than 7. We'll speak of pH in more detail afterwards, but just for now you need to know this. You might have also done tests in your lab where you have to dip a pH paper, and if it is an acid, it will give a color, and you have a color chart over here, and then they say that this color corresponds to pH 7 or this color corresponds to pH 8. So that is that pH. Bases will have a pH greater than 7, and salts, on the other hand, will have pH always equal to 7. Neutral salts, that is. We also have acidic salts and basic salts, but we are not talking about those salts. We are talking about only neutral salts. So these are the basic differences between acids, bases and salts.